Okay, the endpoints of the diameter of a circle have coordinates 2, 0, and negative 2, 3. Find the length of the radius of this circle. Okay, so let's just imagine a little plane, and let's plot these points. So we have point 2, 0, so just go 2 in my x and 0 in my y, so that'll be this point right here. That's 2, 0. Negative 2, 3, that will be negative 1, negative 2 to the left, and then 3 is my y, so 3 up, so 1, 2, 3. So this point is at negative 2, 3. That is my other end of the diameter. So let's just, these are the other end of the circle. This makes a diameter. So the circle looks something like that, where this is the diameter of the circle. Now it's asking us, though, to find the length of the radius. The radius is just going to be half of your diameter. So if we can just imagine this diameter, if we can find out the length of the diameter, we just divide that by 2, and that will give us our radius. All right, so to do this, let's make this circle, let's imagine it being like a triangle. Let's picture it like a triangle. And now that we've got it pictured like a triangle, we can just find, if we can find out our leg here, whatever the hypotenuse is, that's just whatever our diameter is. So if we can find these two legs, we can use Pythagoras' theorem. Pythagoras' theorem, which is a squared plus b squared equals c squared. All right, so let's find out what these are. So this value is just the difference between my x value. So I was at negative 2. From negative 2 to positive 2, this is just the distance that we traveled of 4. That's just the distance of 4. Distance of 4. Now from my this side, this is just the differences of my y. So I was at 0 here, and I went up 3. So this is a distance of 3. So in other words, I can just say 3 squared plus 4 squared is equal to, I'll call this c. This is my diameter, but for the sake of label this c is equal to c squared. So 3 squared is equal to 9, 4 squared is equal to 16, and this is equal to c squared. So 9 plus 16 gives me 25. 25 equals c squared. Take the square root of both sides to cancel out the square sign. We get c is equal to principal square root of 25 is 5. So 5 equals c. Now c is my diameter, but I'm not looking for the diameter. I'm looking for my radius. My radius is going to be half of that. So I take 5 divided by 2, gives me 2.5. That should be my solution. Okay, if f of x equals the absolute value of 2x minus 4, then find f of negative 3. Okay, so all this says when you have f of negative 3, that's just saying that's an input, that's your x value. So you're saying x is equal to negative 3. Let's just plug that in for x. So let's rewrite this. So f of negative 3 is equal to 2 times negative 3 minus 4. So 2 times negative 3 is negative 6 minus 4. So I'm just rewriting. What I have negative 6 minus 4 is negative 10. Okay. So, but your solution is not negative 10. These lines mean absolute value. All absolute value means is you just take whatever the positive of that is. So that would be equals positive 10. And if you want to see how to plug in absolute value on your calculator, we could have just done this. If I want to just plug this in on my calculator, I could have said, okay, your absolute value is under your math number ABS. That stands for absolute value. So math number ABS, absolute value. Enter, and I'll just do 2 times input negative 3 minus 4 gives me 10. So that's how you plug in your absolute value on your calculator. So that'll be E, 10. Okay, if 2c minus d equals 3d minus 2c, what is d in terms of c? Okay, so what is d in terms of c? So we just want to take this function and basically rewrite it, but now we want to have d on its own, so it'll be d in terms of c. So let's just get all of our d's on their own, and that will end up giving us our new function. So we want to find out basically how many c's we would have d being. So let's just do this. Let's get d on its own. So we got 2c minus d equals 3d minus 2c. All right, I'm just going to get all my d's on their own, and I could either do subtract 3d to both sides or add d to both sides. I'm going to add d so that my d's stay positive. So I'll add d, those cancel out. I get 2c equals 4d minus 2c. So we want to get d on its own. So let's get rid of this minus 2c. Add 2c to both sides. Cancel out. I get 4c equals 4d. Get rid of that coefficient. Get rid of that 4 on front of the d. So 4 multiplied by d, the opposite of that, divide by 4. Divide by 4. Those each cancel out, actually. And we'll get c is equal to d. So d is just equal to c. So d in terms of c, that's just c. Okay, the complex fraction 3 minus 1/2 divided by 7 over 2, 7 halves minus 1.5 is equivalent to which of these? Okay, so if you're not crazy about fractions, you can actually just use your alpha y equals to tackle this whole thing for you. I'll do it that way first, and I'll do it using actual, do it by hand after this. But first I'll do it this method. So let's set up my fraction. So up top I've got 3 minus another fraction. So 1 over 2. All right, now on the bottom I've got a fraction, 7 over 2 minus 1.5. Whoop, let's mess that up a little bit. Let's see. Minus 1.5. And let's see how, oh, I forgot to do my minus sign. Minus 1.5. There we go. Let's see how it deals with this. Now that gave us 1.25. So 1.25, this is really just the same thing as saying 5 over 4. If you want to see how to get that into fractional form, you can do alpha y equals. Instead of turning to fraction, we go to the bottom where it says fraction to decimal. So this will take what we had and put it into fraction form. So take a decimal, put it into fraction. So 1.25 is just 5 over 4. That's A. Now, if you want to see how to do that by hand, I've got 3 minus 1/2 divided by 7 over 2 minus 1.5. This is the same thing as saying 3, and to make it have a common denominator, this is just 3 over 1. So to get to have a common denominator, that's just 6 over 2 minus 1/2. Okay, and now 7 over 2, this is 1.5 over 1, so to make it have a common denominator, just multiply both parts by 2. That'll give me minus 1.5 times 2 gives me 3. So we get 3 over 2. 6 over 2 minus 1 over 2, that gives me 5 over 2. So 5 over 2 divided by 7 over 2 minus 3 over 2 gives me 4 over 2. 4 over 2. Now when you're dividing by a fraction, you can rewrite that as multiplying by that fraction just flipped over. So this is the same thing as saying 5 over 2 times 2 over, 5 over 2 times this flipped over, so 2 over 4. 2 and 2, those guys would cancel each other out, and I would be left with 5 over 4. Okay. Okay, the intervals of weights of a group of middle school children are recorded in the table to the right. What percent of the group is found in the mode? Okay, the word mode, when you see mode, that just means the most common score that came up. So I'm going to look at the frequency and see which of these ones is the most common. Okay, which one? Right here, 91 to 100. I had that 21 times. So that's the biggest of my frequencies. So that's the most common one that came up. So it's asking us what percent of group is found in the mode. This is my mode. To find out the percent, let's just take whatever that number is, divide it by the whole, by the total, and then multiply by 100. So if I do 21 divided by 70, multiply by 20 divided by 70, and then I'll end up multiplying this by 100 to get it in percentage terms. So let's do 21 divided by 70. So that's 0.3. To get into percent, remember cents, there's 100 cents In a dollar, there's 100 years. In a century, that cent means just of 100. So 0.3 times 100 gives me 30. So this is 30%. So that is E. 15. If the graph of y equals x squared is translated 3 units to the right and 2 units down in the standard coordinate system, then the translated graph has which of the following equations? Okay, so there's several ways you could do this. We could graph, you could think, okay, what y equals x squared would be y equals x squared looks like this, and it's saying move this 3 units to the right and 2 units down. So in the standard coordinate system, so if I want to find out which of these graphs actually would be this one, but 3 units to the right and 2 units down, I could just try graphing each of these and see which of these does that. So that's one way to do it. It's not the way I would usually do it, but if you're just trying to find the answer, that is a way to do it. So let's see. And I'm going to actually go straight to the right answer on this so that you can just see what that looks like. So it's translated 3 units to the right and 2 units down. So if I were to go, that's going to end up being this one, C. So if I do x plus 3, here we go, squared, minus 2, that went 3 units to the right and 2 units down. Now that one, clearly I did that wrong. That didn't go 3 units to the right and 2 units down, so I guess it's not C. My bad. But I will explain actually how we can do that. This time I think I'll get it right. So 3 units to the right and 2 units down. That went 3 units to the left and 2 units down. So let's try doing something like this, but the opposite. Let's try, we're going to want to flip that x, the one that went with the x. So let's try this guy. Let's try A out. So let's try graphing minus 3 squared minus 2. Let's press graph. Let's see how this looks. Okay, good. This went 3 units to the right and 2 units down from our original graph. So it's going to be A. So when you get a problem like this, we're trying to say which of these is like that. You can just try graphing each of them and see which one actually moved that original function. Okay, so that's one way. So we know that's A. Now the other thing is if you remember your vertex form of a quadratic function says a times x minus h squared plus k, where h, k, this represents your vertex. This represents the vertex. So basically, if I want to go 3 units to the right, my h value, which is just, this is x and y, my h value is just going to be, if I want to go to the 3 units to the right, that's the positive. You got to flip that because it's minus h, because the number's being squared, things being squared, so it ends up flipping. So if I want to go in the positive direction, I'm going to have to end up minusing from that. So that's why it is x minus 3. It's the opposite direction of that. 2 units down, that's going to be my k value, that k. So I'm going 2 units down, and because this is just a plus k, it's not being flipped or anything the way this one was. There's no square on it. This k is just going to be whatever that is. So 2 units down, that's 2 is in the negative direction. 2 units is in the negative direction. Well, I really messed this one up, huh? Let's look at my graph again. Did I type that guy in actually? Let's see what I actually typed in. I didn't type in A. I typed in E. Look, x minus 3 squared minus 2. That's E. That's E. I actually typed this guy. I didn't type down. That's not right. I need to go 2 units, going 2 units down, and this is what I actually typed in that gave me that graph. See? So E is my actual answer choice. So you see that 2 units down is my, that represents the y value. So I'm going down, and that's where this negative 2 comes from. But it doesn't get flipped because there's no squared on it like you have with the x.